Today's lesson is composition of functions, or composite functions. And as you might expect, the word composite implies that you're putting more than one thing together. And let's take an example from real life. Let's say that you have a radio. The input to the radio is electricity. The output of a radio is a sound wave. Now let's say that you are going to record that sound wave. You will have a recorder. The output of the recorder is, let's say, a disk or a signal that is stored on a USB memory or something of the sort. So you have effectively two items, two machines, two processes that were such that the output of one was the input to the other. This is very similar to composite functions. In order to understand that fully, let's consider a function f of x that's equal to 2x plus 3. And to understand that, let's draw this in a block diagram format. The first box that we have is a multiplication by 2. So when x comes in, it's multiplied by 2, and we get 2x coming out of this box. And the next piece of instruction is add 3. So your output, which is f of x, is equal to 2x plus 3. You can think of the function as a set of instructions. There's an input, we're calling it x. It comes in, it gets multiplied by 2, then you add 3 to the result and you have your output. Now, what if the input was 5? 5 is multiplied by 2 to give me 10. Then we add 3 to get 13. And this is exactly what we do when we say that f of 5 is equal to 2 times 5 plus 3, which is 13. In this case, we replaced the x on the left-hand side by 5, and therefore we replace the x on the right-hand side by 5 as well. And this is the input, and this is the output. Now, the 5 just simply followed the instructions. The instruction of this function is multiply by 2, add 3. Because we changed the input, we simply change the process, but the instructions remain the same. Multiply the input by 2 and add 3. That's why we got our 13. Now, this can be extended to ask ourselves, what if the input was C? So f of C would be simply multiply the input by 2, 2 times C plus 3, which is 2C plus 3. And as you notice, we have replaced the x by C on the left-hand side, and we have to replace the x by C on the right-hand side. What if the input was 6n? What's f of 6n? Again, multiply the 6n by 2 and add 3. This gives you 12n plus 3. What if the input was f of p plus q? Well, you multiply that by 2, but don't forget the brackets, and you add 3. What if the input was x squared? The output will be 2x squared plus 3. And what if the input was 6x minus 4. Now we're replacing x on the left-hand side by 6x minus 4. So we should replace the x on the right-hand side by 6x minus 4, and this becomes 2 times 6x minus 4 plus 3, giving 12x minus 8 plus 3 is minus 5. If we have two functions, let's say f of x and g of x, and let's assume that x goes into g first, like the example with the radio and the recorder. X goes into the function g and goes out as g of x. And let's say that this output becomes the input to another function f. Now the function f takes in g of x, so g of x is the input to the function f. So the output would be, rather than f of x, it's f of the input, so it's f of g of x. And this is the composite function. This is how we say that it's a composition of g and f. This is one notation, and you can express the same idea by saying f follows g of x. Now f follows g of x means that the function f comes after the function g, and that the output of the function g was the input to the function f. This is the idea of composite functions. Let's look at certain applications in the realm of mathematics. Let's say that g of x was 5x plus 1, and that f of x was x squared minus 3. What's g of f of x? Obviously, what's going into g is f of x, so we look at this function g. Here we replaced the x by f of x, so we should replace the x here by f of x. So this becomes 5 times, instead of x, f of x plus 1. But you know what f of x is, so this becomes 5 times x squared minus 3 plus 1. And after expansion and simplification, it's 5x squared minus 14. Now the first step, this step, is something that you can do in your head. Let's take another example. Assuming that h of x is equal to 3 divided by 5x minus 2, and that j of x is 6x minus 1. Let's find j of h of x. So h goes into j, and we're replacing the x in j by h of x. So this immediately becomes 6 h of x minus 1. Again, this is the step that you can do in your head. And this equals 6 times 3 over 5x minus 2 and the minus 1, which simplifies into 18 divided by 5x minus 2 minus 1. Now that we've seen how we can create a composition of two functions, let's think of a slightly different problem, and I want you to think about that for tomorrow. Assuming that f of x is equal to 5x minus 3 and that g of x is equal to 6x plus 4. What I want is f of g of 0.5, not f of g of x. Now I want you to think about that, and we'll see the best way to do that tomorrow.